Hello again, we are moving on with Act 3 and the next challenge is something that gave me a bit of head scratching because I think I found the vulnerabilities mentioned in it, but I couldn't really piece them together, at least not the way I think it was intended. I managed to solve the challenge regardless, but I'm not really sure what happened there. Also, I probably have to pause here for a second and just tell you that the reason why you see the videos uploaded in batches is because, well, I'm still being rate limited by the uploads and Google. It's a bit frustrating. I guess when the channel grows a bit larger, then this will be lifted. And I would like to thank you for watching these videos. You are the ones who, well, possibly will eventually make this happen. And I'm very grateful that when I upload the videos, I see people already watching these, liking the videos. So thank you very much. And this really keeps me going. I know that I kind of abandoned the channel, but if you are watching this and you like the videos, please consider subscribing. It doesn't cost you anything. Thank you very much. And let's see the challenge itself now. So this challenge is called Snowcat RCE and Privilege Escalation. And the condition here should be really an OR condition instead, or something like that, because you can find easily the remote code execution. Well, you have to craft a proper payload, but after that, I was kind of stuck and I didn't really know how I am supposed to use that to get to privilege escalation. I just started looking at the privilege escalation side. So, and I succeeded with that one because you just get a terminal on a system where everything is running on. So I don't really get it. I'm pretty sure I didn't solve this the intended way. So I'm eager to see the write-ups after I upload the videos. I'm not like influenced by the write-ups anyway, but I don't know. I just don't know how to piece the two together. I managed to find two different ways how you can exploit the binaries that are vulnerable, at least, but I will show you how far you can go with the remote code execution stuff. So we have Tom Hessman, a good colleague from SANS. We've been working together when I was running the DFIR Networks development, and he is going to be the host for this challenge. And you find Tom here in the Networks room, of course, of all places, and you have to talk to Tom about the challenge. Gives a bit of background about himself. He's actually working in his local theater, which I knew before the game, and it's a really fun fact about Tom. And this is one of those free snowflakes out of 5 difficulty level Act 3 challenges. I think the difficulty level is really about like free snowflakes here. So let's get some hints on this. And you will see that the first hint is already referring about injecting commands, calls into the temperature, humidity, and pressure monitoring services. So these are the binaries that are vulnerable. I was lazy and I think I was using the temperature one. I'm pretty sure the humidity and the pressure ones can be used. Let me know if you in the comments if you use those ones when you solve the challenge, if you did this one. And let's get another challenge hint. I don't know how many hints do we have. Snowcat. So if you're feeling adventurous, maybe you can become rude. I did manage to become rude, and this doesn't influence in any way really the game itself. It's just an extra thing you can accomplish basically. So let's get the third hint here. Snowcat is closely related to Tomcat. So Snowcat is actually Tomcat, and it has this vulnerability, which is a code execution vulnerability, a fresh one from this year. So I do like the fact that they give us some, practical things. Clients of mine do use Tomcat, so it will be interesting to see if they actually patch this one. We're going to have some upcoming internal penetration tests, hopefully this year, and we might be able to exploit this. All right, and these are the 3 hints that we're getting. These are actually the 3 things that you can do in this challenge, and this challenge gives you just a terminal. And in this terminal is where you can do all your actions basically. So let me just get to my notes and let's get started. So obviously you want to poke around a bit and discover what you have available. So they gave you some extra hints in a form of notes, and you can also see here the challenge after the login gives you some additional context here. You also have a Python script to exploit the vulnerability. So basically with these tools, Yoso serial and the Python script, you can already start exploiting the remote code execution. Obviously, we want to take a look inside the notes markdown. In the notes markdown is going to tell you about Yoso serial. So this is obviously a serialization issue, and gives you the curl method of exploiting this vulnerability. The Python script, I think, just makes it a lot more easier. So I'm just going to use that one because it's one line instead of like these separate lines here. So we're just going to use Yoso serial to generate the serialized object and then feed it into the Python script that we have. And then you also have some notes on the privilege escalation stuff. So the Python script itself is also here. You can take a look on that one. Probably capital CVE. You can see it has the arguments for the host port, base 64 encoded payload is needed, and then session ID. And it's basically just doing the same thing. It's sending the payload that you create with Yoso serial. We also have here weather-JSPs folder where we have, oops, made a typo there, where we have the dashboard JSP, index JSP, and login.jsp. We can take a look inside these as well. So let's see, index.jsp, it's just a standard login form, nothing super interesting. There's also some snowflakes.js. And later you will see that these are essentially just the, I'm gonna display the login one. These are really just the JSP files on the Snowcat target server, which is running locally apparently, but we have a limited user here. So the username is user. And dashboard JSP is the place where you have references to the vulnerable components being executed on the server. So you can see these 3 lines here. You can also see that there is this key value. And the goal for this challenge is to find another key that is used by a different application. So this is a key that we are basically being provided with. And then you have these. Now I realize that probably the intended way, not that just I'm talking through the solution, was probably to read up these files. So I think there must have been a mistake, and the weather JSP folder shouldn't be here, because then it actually makes sense to figure out that these are the binaries that are being called by the application. So not really sure why we are given the source code. Without this, it would actually make sense, but that's okay. So it's still an interesting challenge, even like this. And one thing that we can also do is look at running processes, and we will discover that there is a user local Snowcat conf directory. If we go into that directory and list the contents, we'll see that all the files and directories here are owned by the Snowcat user, and we can't like we cannot do anything on the directory, so there will be permission denied. I just realized that I have a weird like command here. Let me just correct my notes. My I guess my OCD kicking in. There is netstat here. aptn netstat. If I could type. There we go. And we see that there is port 80 open and listening on the server. So if we just go and use curl, again, the theme for this year's challenges is really to use curl. We see that this is actually the login HTML that we JSP rather that we saw earlier. So if we go back to our folder and look at here and look at the login form or index, sorry, index JSP was the one that I was thinking of. So this one, and what is returned is the same. So that is the Snowcat web server that is running here. That means that we should be also able to get to the dashboard. Well, we don't have a valid session here, so that's not going to work. And it's just giving us, let me see if I can see the message user password. So it's just telling us that like, yeah, we're not going to, oh, because it's a redirection. So we're trying to fetch here the dashboard JSP, and you can see that it's redirecting us back to index JSP because we don't have a valid session here. Yeah, I had to tell curl to do a -l here. So without this, this was the original like thought process here. We see that it's just a redirection. If you do -l, curl actually follows the redirection. So we're being redirected back to the login screen, which is kind of intended as the behavior for most applications. And we also have in our home folder the Yoso serial jar file, which has a set of different kind of payloads, and we're going to mainly use common collection 5 for the exploitation. This one will generate the base64 payload for us. So we are going to first test if we can actually exploit the remote code execution vulnerability. And I am going to use a payload where we're just going to create a file in the temp directory. So by default, we shouldn't have anything in the temp folder. There we go. So we're going to generate a payload, which is going to be just creating a file in Pond, and we should see this file created with the Snowcat user that is running the Snowcat server. Oops, that's not what I wanted. That's the entirety of the payload. I just wanted to add out the content, and there we go. It's the actual same payload that I was pasting in earlier. It's just that's the payload that is generated. I'm just showing you that. And then we can run the Python script. So here, what I'm doing is just calling the Python script with the parameters, and we're going to feed in the base64 encoded payload. I called to my aid Claude for this to figure out the exact command syntax for Yoso serial. I don't really use Yoso serial that often. I think I used maybe once or twice in my career, and should probably do some practicing on serialization vulnerabilities. And so for the Python script, we're just feeding it into the base64 payload here. And we get back stack trace, Java stack trace, that's actually fine. We don't really care about it. But it's just the good indication that what we would like to see is actually what happened. Where do I have the ls for the temp folder? There we go. And we can see that indeed we do have a pwned file created in our temp folder as Snowcat. So this is a great indication that this vulnerability is actually there and can be exploited. We just need the right payload. And I came up with some very basic payload here. So what we're going to do is we're going to make Word readable, writable, executable that Snowcat folder for the Snowcat user. And later, hopefully I also made the same thing for the, so we're going to do this for the Snowcat home folder. Actually, I think I did this one first, but this is going to be a dead end. So I'm just showing you that this might be a great idea. And then I'm just going to use the Python script to send in the payload again. And now I should be able to, from my home directory, get into the Snowcat directory. And we'll see that there is a flag txt there. And I was very excited. Although the challenge does says that you need an API key, not a flag. And this is just some dummy flag that was probably created with the creation of this like challenge container. So this is a dead end. That's not what we want. A better direction, which still kind of leads to a dead end afterwards, is to just, oops, I need to go back to my own folder here. So what we're going to do is then poke around in the user local Snowcat, but it's still going to be sort of a dead end here. There's my Python command. We're just keeping hitting up arrows. And now, if we go back to the local Snowcat, yeah, it makes everything executable, but that's fine. We see that now everyone can do anything under the Snowcat folders. So that means that we can get into, for example, the config folder. Isn't that? Oh yeah. Oh, so I'm just gonna cd in here, and we can start poking around. You know, config. Let's add the files here. So that's something that we couldn't do before. Now, what I did here was to search for key, hoping that I might find like API key. So you can search for grep, and then Rail is going to do a recursive search, force grep to look inside any file that it finds, even if it contains binary data. It will not ignore and skip it after the first couple of bytes. So that's the A. I is for case insensitive search, and L is just listing out the file name instead of the match. You can replace it with an N and then it will show you the match as well, but that usually pollutes your terminal output a lot. So initially I just want to see the list of files. So for key, and I think I haven't even tried it for API, because in the source code we saw key, but we get pretty much the same list here for API. Let me take a quick look. I don't think there's anything here that is useful for us. Yeah, it's still pretty much the same thing. However, in the list of the key search, there is one which is under the web app root. There is weatherdb here. So weatherdb, these .db files are usually SQLite. Well, we can verify that quite easily. Just do paste. And it seems like it's a SQLite database, actually. Didn't do this command when I was doing the challenge solution, so probably a good idea. I just went straight to it because, you know, I wanted to burn through the lower challenges as fast as possible. So we can invoke SQLite and then interact with this SQLite file. We can get the tables we see that we only have users, risking that I will make a typo with the select statement. I'm going to copy this. I know it's just a select star. And we can list out here valid users. Now, these kind of look like these 64 encoded passwords, or maybe they're actually hashes. So I don't think any one of these is interesting, or maybe they're just like, you know, random passwords, just happen to be base 64. But there is this one here for the admin that looks like clear text password, because it spells weather, be cold, and this is an admin user. This is for the actual website, and that's pretty much what you can get out of this, because you already have the source code for the application. So I didn't really see the value of going any further than, well, you can still use the admin credentials. I can show you that one. But if you go, for example, in the Snowcat, what is it, web apps root folder, you will see that we just have the same files here. Nothing super, you know, exciting about this one. I'm gonna copy this one here as well. And yeah, that's pretty much it. You can verify if the admin user password is actually a valid one. I did that. So you can do a curl on this. Paste, and hopefully we will get cookies. Let's do cat cookies, and the cookies, we have a JSession ID here, so we can try to, with the cookie value, access the dashboard, and it actually gives us back the temperature, humidity, and pressure values. But after that, the problem is that this is all that this site does. You don't have any user input here. If you look at the actual source code on the dashboard JSP, so this is in the web root. It's the same exact code. And I think what they intended to do was not having this code in the user directory, because this is not something that you can access. So after this, it would make sense to then realize that, oh, you know, there is this temperature and humidity and pressure binary. So I think the mistake, maybe Tom made that mistake, was to place the source code there, because from this we can learn that these binaries are on the system under user local weather. Otherwise, well, there might be a way to see this one, but I can't really think of an easy way to realize this. So I think that's the intended way. So we discover like, oh, look at these are binaries on the system, and then we can take a look at those binaries. So this is as far as you can go with the RCE, and I think this is as far as you should go with the RCE. Then we see that in the user local folder, we have the weather directory, which is owned by weather and also the weather group, I think. And because I think it's a group. Inside, we have the humidity, pressure, and temperature binaries, which have the SUID bit set. So the SUID bit is always a good indication in a CTF game when you have like custom binaries, that there might be a way to use them for privilege escalation. So I started poking around with these. If you just invoke the binary without providing a key, it will complain that it needs a key. We got the key from the source code. So when you actually invoke the binary with a key, it returns back some, and I think these are just probably random values for the temperature, humidity, and pressure. Okay, so I did some very basic rudimentary reverse engineering here. If you go against this binary, let's pick the temperature one. I'm pretty sure it works with the other ones too. But I haven't tried it, so it's a good exercise for everyone. We see that we only have 133 strings, and if you run strings against it, there are already a few rather suspicious or potentially exploitable things here that we can see. Now I kind of skipped through the system first, but then I circled back later. We can also see that there is a config file inside the weather folder. We can also see that it reads some data file for the temperature. There is also this log usage file being referenced here, and we can see that there's user local weather keys, authorized keys. So we see already a couple interesting things here. And if we would like to, exploit some sort of command injection, and that was my initial thought, that there must be some sort of command injection, you are often going to deal with exec or system or some bash kind of calls. And sure enough, there is a system call here. So I was also testing other things, like do we have something like strace here, and apparently that's not found. So that's as far as I went with this, but there is a system there. And there's also this log usage script, which you can see that right after it, we have this format string with 3 inputs. So this is also a good indication that, because they are just coming right after one another, this log usage script is probably using some sort of input here. We can also see that the command must be passed here in single quotes if we want to inject something, because these are all in single quotes. So really good indications there. And I also noted here somewhere keys, authorized keys. I don't really see the reference on the substring. There must be something here as well that I do not see now on substring. So there shouldn't be an exact match, basically. So what we kind of suspect, and we will be able to verify this later, but I kind of suspect that there's a call that is something like this. So there's probably a system call, and the log usage script is called. So this one, we do not see any potential for path injection. Turns out inside this, there is actually path injection. And then it calls the temperature, or well, whatever binary it needs to call. And then we need to provide the key here. So these are basically the free strings, but this is exploitable. So I can put my user provided input here, and in the key part, I can add, something. Let me just try to show you what it would look like. I could do, instead of this, I'm gonna Control C this. I could do something like this when I insert my input, and then I just need to be aware of the fact that I need to close the last 2 quotes here. So I need to match those. If I don't do that, then I'm probably going to just get an error message here. And we can actually try that one out. So if you are not closing down the strings, you won't be able to break out from the quotes. So here I tried a couple of these. I tried a bunch of these different approaches before I actually went into the strings and properly understood what it happens. This returns just the temperature part, which is still a good sign, but we couldn't get back the ID command. If I am not matching the right amount of quotes, so I'm trying to, close this quote, but after the ID, I don't have the quote, it executes the temperature binary, and then it complains that I have an unterminated quote string. So it's, you know, typical command injection problems there. But if you actually like think about the format string and how it's terminated here, it actually makes sense that this is what you need to do here. You can see that now this actually, no, doesn't run as the root user said, but as Vedder, which is still pretty good. And I just realized that in my notes that I'm missing a closing bracket. All right, so this means that as a Vedder user, since the Vedder user is the owner of the keys directory, if we do something like this, and we list out the keys directory, we see that we have the authorized keys in there. Again, we don't really need to do all these gymnastics. We can just go straight to the authorized keys and get it out. I'm just gonna echo a new line here. Oh, there's oh, because I'm missing the actual binary call. There we go. Yeah, that's much better. So we can list out the keys, or you can just, you know, go lazy. You already know that there's an authorized key file from the strings. I, for some reason, missed it the first time. And then when I was going back to the challenge to do path injection, I realized that this is already in the strings output. So this is the second key here. And if you submit this one, you get the challenge. Let's move on though a bit. So let's put this one aside. And I want to show you something else as well. So this was command injection, exploiting the command injection vulnerability inside the temperature binary. And again, there's two other binaries. They probably work the same way. But we can also try path injection. So the trick here would be, and I think this should work. Did it with something. I did it with temp, but this should also work. So you can check whether anything is referenced without the full path. So if we reset the path and we get error messages like these complaining that we cannot find date or make directory, that means that somewhere along the way with this binary, and we saw that it's invoking some additional binaries like this log usage 1, right? So probably in the log usage 1, there's references for date and make directory. So what we can do is we can create, and I'm going to create this in the temp directory. We can create a file in temp date, and I'm going to set the path to temp. It's going to use that date binary. And we saw something similar in one of the, I think it was one of the first ACT challenges, or maybe the second one for path injection. We did something very, very similar. Yeah, it was the neighborhood alarm system where we had to exploit some path injection vulnerability. This is very, very similar to that concept. So we're replacing the binary in a folder where we have write permissions, but actually placing a binary there, and then execute the program. The only trick here is that we are setting the path for the binary. In the neighborhood alarm system, we already had the path containing one of the directories where we could place a binary. So it was just basically dropping there a file. And we are using this opportunity to list out the authorized keys. So that means I also have to make this one executable. Don't forget to make it executable. And we should have now this date file here. Awesome. That means that if I now call the binary by setting the path to temp, it should create now in my temp folder an authorized key file. And I just wonder if this is actually, this is owned by the Vedder, but it's word readable actually. So we just moved, well, made the copy of the authorized keys, but it's word readable. I got lucky here. Otherwise, you would have to just, set the permissions. But I was able to do this with a one-liner in this case. So I'm going to set these with the authorized keys. And again, we have the solution here. Now, I'm still not going to submit this because I don't want to reset the terminal here. We can also get root. The trick here is to see where is the actual part where we drop down from root to this weather user. And we saw that the weather directory contained a config file. This is actually what we need to override. This is owned by weather. Actually, I could have just, pointed here to the config. So this is owned by the weather user, and that means that we can, with the same vulnerability, actually override this. So I tried. Oh, there's one more thing that we can actually check out. So this is a good opportunity to also check the log usage script that is under here. And this actually reveals how we were able to exploit the path injection. So we see here make directory referred and date referred. This is vulnerable to command injection. Cool. There's also like a reference here. Yeah, so this is just as a side note, but what we can exploit now is, if we want to become root, is the configuration. So we're just going to change this one from weather. Now, I initially tried to do something like this. Don't do this. I don't know why, but the -e totally breaks the format of the file. So instead and this one I asked Claude Code, like, what am I supposed to do here? Not Claude Code, but Claude AI. And it recommended me to use printf instead. So we're basically just overriding and replacing the weather user to root. So now if we go back and check the weather config, you can see that I changed this to root. And then what we can check is that when we execute the temperature binary, we are now executing commands as root. And that is great because in that case, we go back to the home folder. Oops. We see that there is an IC user here, aside from Snowcat and the weather user. And we can peek inside the IC users folder. There's a goal file. And then we can look inside the goal folder. Now, I actually haven't looked at the root folder, I realize now. So we should totally do that. This is me going off script, but I want to check what's inside the root folder, if there's anything. Okay, inside the root folders, there's also the goal file, apparently. So totally same stuff, but I mean, we never know if this is really the case, so I'm going to do the same thing here and just save this to my notes. Copy this, and we are going to check what's inside the goal in the root folder, if this is the same or a different file. I just need to clear the terminal. And yeah, it has the same exact content, so no big reveals here, unfortunately. Bummer. Could have been something extra here. So either the IC folder or the root folder contains the goal. All right, but so just going back here real fast on the authorized keys that we extracted. The second one is the one that we were not aware of. Just make a copy of this. and then we're going to submit this key. And there we go. We got the achievement. We can talk to Tom. It's going to be very, very grateful for our help. And that's all for the challenge itself. So like I said, this is a pretty well structured and architectured challenge. It's just that it doesn't make too much sense to deal with the RCE. You already have the information for the privilege escalation inside the weather-jsp folder in your home folder. So you can just basically go straight to that one. If that one is removed, actually, it will be a pretty cool challenge where you need to exploit the RCE to realize what binaries are available and then go on. So I think this is the part where the architecture went off the rails, but it's still really good as a learning opportunity, and I am eager to see how other people solve the challenge. But we are done with this one, so let's move on to the next challenge in the next video.